So hi and welcome everyone, welcome back. In this section we are gonna be talking about controlled access protocol. Up until now we have talked about random access protocols and we discussed Aloha, which covers pure Aloha, slotted Aloha. Then we talked about carrier sense multiple access and its different types, including one persistent CSMA, unpersistent and probability persistent CSMA, and then we talked extensively about CSMA with collision detection, which is used in Ethernet networks, and then we talked about CSMA with collision avoidance, which is used in Wi-Fi network and wireless mobile systems in general. And now we move on to talk about the next part, the other part of multi-access protocols, which is called controlled access protocol. And one of the key methods here for controlled access protocol is reservation. We have reservation and polling and token passing. So token passing is very easy, very straightforward. Basically, there is a token that's being passed among nodes. The node that has the token has the right to transmit. And as you can see, this is controlled access. It's not anymore random. And for polling, it's like voting. Who has the most data? Who has the most critical service to send? Who have whatever. You have multiple parameters, and the central node determines which one has the right to transmit. Reservation is just like when you want to make an appointment with your advisor to meet him, or when you want to make an appointment with a dentist for your checkup, whatever. It's you reserve. You basically, if you want to rent a car, you reserve. If you want to rent anything that's rentable, you just reserve it first. If you want to book a hotel room, you reserve it first, and this is how it works basically. So what's reservation? Reservation. A station needs to make a reservation before sending data. This is what it means basically. In each interval, a reservation frame precedes the data frame sent in that interval. If there are n stations in the system, there are exactly n reservation mini slots in the reservation frame. Each mini slot belongs to a station. When a station needs to send a data frame, it makes a reservation in its own mini slot. And this is the diagram that shows the procedure of reservation in controlled multi-access protocol. The stations that have made reservations can send their data frames after the reservation frame. So you have here the reservation frame. There is a frame, think of it like this, a frame dedicated just for reservation purposes. And depending on the number of stations that you have in your network that they are allowed to transmit, you have number of slots inside the reservation frame. If you have 5 stations, you have 5 mini slots in the reservation frame. So assume that mini slot number 1 is reserved. This means that data coming from station 1 can be sent. Assume you have a reservation frame like the one on my right hand side. You have the sections colored by yellow, which is mini slot number 1, mini slot number 3, and 4. Of course, if the reservation is on, the value will be 1. If there is no reservation, the value will be 0. So in this case, data station reservation mini slot 1 means data station 1 is allowed to be transmitted. Reservation mini slot number 3 means data station from 3. Reservation in mini slot number 4 means data station from 4 can be transmitted. And the reservation frame always precedes the frame that are going to be transmitted, the frames that are expected to be transmitted. So this is all about reservation. This is what reservation mean. And polling, we already talked about polling and token passing, which are all kind of controlled access protocols. So in the next lecture, we are gonna maybe give you a little bit of more detailed description about channelization protocols, which are including FDM, TDM, CDM, OFDM, and hopefully NOMA. So these are the things we have covered so far. So thank you everyone, and meet you in the next lecture.